Hi, everyone. Welcome to the webinar. Hopefully you can hear me okay. We're using a new platform today, so feel free to use the emojis below to let us know how we're doing. And of course, you can use chat and Q&A too. My name is Torey Penrod-Cambra. I'm the Chief Communications Officer here at HighByte, and I'll be your moderator for today's panel. Let's jump right in. Awesome. Okay, so I don't want to waste any time. We have 45 minutes and we have a ton of content to cover. So let's discuss trends that are shifting the way that industrial companies, manufacturers are thinking about their system architecture and data governance. Today, I'll start us off with a brief 5-minute introduction, kind of framing up the problem that has caused this mindset shift. And then we'll dive right into the panel discussion. Some of the questions we'll address are those that you saw in the abstract when you registered for the event, and some of them are thanks to our attendees who provided questions when they registered, and some of those we'll answer during the course of the panel discussion, and some of those we'll save towards the end. So for those of you that put the extra thought and work into sending those questions, thank you so much. And then finally, we'll wrap up with some Q&A, either the questions we didn't get to from the registrants or those that come up live. And just a bit of housekeeping, since I know we always get these questions. Yes, the webinar will definitely be recorded and distributed. If you see any slides or diagrams or images here that you're interested in, reach out to myself, John, or Aron, or sales@highbyte.com, and we can get those materials over to you. And finally, I'll ask that you use the Q&A tool to submit questions to the panelists, and I'll try to field those as they come in, or we'll save them towards the end. And of course, would love if you just took 20 seconds at the end of this webinar to answer 2 brief questions, give us a little feedback, let us know how we did. So without further ado, let's talk about the problem. The problems that we want to dive in on today. And this is kind of a concerning stat. So according to McKinsey's study of more than 400 manufacturers, 74% have failed to scale their Industry 4.0 use cases. And that's pretty bleak, considering how much hype and excitement and potential that Industry 4.0 holds for industrial companies. And to me, this just means that pilot purgatory is unfortunately extremely common. So let's look at the problem architecture of why. There's a lot going on in this infographic, but if I start up towards the cloud area in the top right-hand corner there, I think it really is all about, first, simply dumping raw unformatted data in the cloud is inefficient and inexpensive. And I think that was like kind of the first strategy that a lot of companies took to begin digitalizing their business. And the reason companies care at all about digitalization is they're trying to remain relevant and competitive by improving operational efficiency. And it requires sharing usable information in the right format with the right people, regardless of where they sit in the organization. But that gets really challenging, right? So IT, the professionals looking across the enterprise, do not understand operational data, or what we'll refer to today as OT data. They just simply lack the context for it. And while OT has this context, it's either siloed on-site HMIs or their own inherent domain knowledge. They don't have the tools to be able to get this and to their peers in IT, so it can be used for analytics and line of business decision making. And this is complicated by the fact that when we're talking to customers, what we typically see is that the stack is comprised of a lot of ad hoc custom code and point-to-point integrations that really just isn't very maintainable or scalable. And as we see it, the problem's getting more complicated as factories are generating more data than ever as more sensors and connected devices increase. And also with the rise of AI and ML, the number of applications demanding this data is rising too. So it's complicated. And to kind of summarize those 2 challenges, we'd say that, the use cases that rely on industrial data are growing exponentially, and developing a data architecture that works for the enterprise to fully connect, not only all of its sites, but its suppliers and customers too is difficult, and it's only going to become more difficult with time. So that's our take, but I would love to hear from everyone else what problems you are facing when it comes to data architecture and governance, and that might be able to shape some of the questions that we have today for John and Aron. So I'm going to start a poll. I'm going to give everyone some time to respond to that. So the biggest challenge you face with your system architecture, I believe actually you're able to select multiple. So if multiple apply to you, then please do so. And these include data access, contextualizing this data that comes from the plant floor or industrial systems, integrating new ones or maintaining the ones you've got, rising cloud storage or processing costs, normalizing brownfields as they're acquired, or maybe you have other challenges. So I will leave this open, continue to see some responses come in. Great. Give it about 10 more seconds. A lot of responses. Okay, good. A little coffee. Okay, great. I am going to go ahead and close the poll. And the way that you can see the results of the poll is just to head over to your polls tab and look under closed. And there you can see the results of everyone's feedback. And it looks like, what's leading here is contextualizing industrial data for IT and line of business. We see that very commonly, and we'll talk a lot about contextualization today. Let me pop out of here. Okay, good. So now let's talk about how we fix all this architectural fragility and this problem of contextualization. I'd like to introduce my colleagues, John Harrington and Aron Semle. John's the Chief Product Officer of HighByte. He's focused on product management, customer and partner success, and company strategy. He spent his 25-year career both delivering software to manufacturers and working for manufacturers in operations roles. And Aron Semle is the Chief Technology Officer of HighByte. He's focused on guiding the company's technology and product strategy through product development, technical evangelism, and supporting customer success. And Aron has more than 15 years of experience in industrial technology. And I have to say that every time I talk with John and Aron, even though I've been in this industry now for over 10 years, I learn something new every time. So I hope you will today as well. So John and Aron, thank you so much for joining this panel today.
You hear a lot of the same things, Torey, too. So you can.
In fact, you said I have 25 years in the industry. I feel like the last 5 have been the most intense, and maybe count for multiple. But I think the 3 of us have been involved in those, and that's been where we really focused in on this data ops challenge.
Okay, well, you really threw me a softball there, John. I'll start with the first question, which is, what is industrial data ops?
That's a great question. Let me bring up a quick image, or maybe, yeah, let me see if I can bring up an image and then I can talk to that. I think people can now see a slide that we put together. So when we talk about data ops, it's a discipline. It's a discipline that companies need to start utilizing within their organization. So as Torey commented, or as you commented, Torey, the challenges today are, how do we leverage data across the enterprise? How do we leverage OT data across the enterprise? So when you think about who are the team working on this, it's more than just the OT team. It's now the OT team, the IT team. We see a lot more new titles that we commonly have not seen on the OT team working together. So data engineers, data analysts, enterprise architects. It's also including the line of business. So the line of business are the people who need this data, and it's bringing them together. So it's really recognizing that this, with Industry 4.0, the data is spanning the deep OT team all the way to the rest of the enterprise, and we need to bring them together, and we need to have OT and IT working together with the line of business. It also recognizes that we're putting together best practices that have been used on, and in many cases in the enterprise IT organization, but have not been used across organizations in the past. So things like data contracts and data governance are not as familiar in the OT groups, which are typically just site level groups and who are very project centric. And finally, it's leveraging technology, and it's leveraging technology from the edge to the cloud to be able to really deliver this data wherever it needs to be used. Some people are running edge-based analytics. Other people are moving a lot of their line of business users into the cloud to leverage the data and to get access to the data. So it's efficiently being able to move that data, make it available to whoever needs it, wherever they are, whenever they need it. So it's really about creating a discipline within an organization around that.
That's great. Thank you, John. Let me ask you a question. So you kind of touched on this a little bit. When it comes to modeling and contextualization of industrial data, how has that changed the way that, enterprise companies are thinking about their industrial data and preparing it? And I guess, what does contextualization mean to you? I think it means different things to different people, and especially different technology vendors use that word differently. So you talk a little bit about context and modeling for us.
Yeah, no, context is critical, and it is a term that's been kind of widely discussed or talked about, but not very often defined. And I think people have different views on it. We've actually put together this kind of diagram that I'm finding a lot of people really like. And it's because what you need to really understand is you need to understand the source of data, and you need to understand what the consumers of the data really need. So in order to contextualize information, we really need to know who needs it, what they're using it for. So what's the use case? Where are they using it? So what system are they locating it? Are they using it locally on their PC in Excel, or are they utilizing cloud-based infrastructure to analyze or to dashboard the data? As well as when does it need to be updated? So we have customers who are getting millisecond resolution data out of machine controllers. We also have customers who just need to update data whenever a batch is complete, or for logging purposes, or they need to update data once every 10 minutes for dashboarding. So it's very critical to understand the time domain when contextualizing data. So I've identified this diagram here where we kind of think of data access, which is all of these volumes of data that is in all these different systems, and some of it is tag-based data that's in a PLC or in a SCADA system. Some of it's sensor data that's coming off various sensors, or data that's in transaction systems like MES systems or CMMS systems. And the key is that all of this data, in fact, we have customers who say, look, I have 750,000 data points in my factory. How am I ever going to get that to the cloud? And the challenge is you can't just put it all in the cloud. Otherwise, it won't mean anything. So you need to add meaning to it, and that's what context is. And it needs to be, so the first piece is taking those data points and adding some meaning around them, something that users who are looking at it would understand. So we talk about contextualizing the data, the raw data, where we put descriptors that make sense, maybe units of measure and intelligent names. We then contextualize payloads of data for the use case, where we're pulling data from different systems, packing it together. And as you can see here, now we're adding not only the process data, but we add in the transactional data from a CMMS. We pack it all in together into a single payload, and then we deliver that up to the cloud, for instance, for the consumption or to the analytic. Then you have to take those standard normalized sets of data, and you want to apply those same standards across your entire enterprise, where you've got different systems that you're pulling at each location, different systems that we have to pull it out. So the key to contextualizing data and delivering it is being able to identify who the user is, where they are, and then being able to standardize and normalize this data into something that's usable by the consumer of it.
That's great. John, you make some good points. And Aron, I want to let you comment on this too. You speak to customers all the time. Talk to me a little bit about how this context gets deployed, deployment practices. How does this play out in the real world?
Yeah. So in kind of to piggyback on John's response, so I really boil it down to three models, and these have similar deployments, but a little different, right? There's the strategy of push everything, add the context when you try to use it in the cloud. As we talked about, that's actually really difficult, right? On the deployment side, you end up dealing with really difficult problems right away. Like we have 750,000 tags. How are we going to get those to the cloud? That's a scale problem, like right out of the gate, that you have to go figure out. That's non-trivial, right? And expensive. And then you get it in the cloud and you use like 10% of it, right? And it takes you a long time to do that. So it's like, okay, what was the value there? We see the other approach of people just try to over contextualize data. So they'll spend 6 months trying to create the perfect data model for every asset in their factory. They'll do a proof of concept where they land that data model in a data lake or warehouse like S3 or Azure Blob Storage. And then the first application will come in to use it. And what happens? Well, we need the data a little different, right? Like that data model is great. Academically, it's fantastic. But when we went to leverage it, we need to tweak it. So now you're doing all these transformations in the cloud. The one that we see, what we're pushing, what we think is it makes the most sense to do it at the edge, right? And what we're really, on the deployment side, what you're really trying to do is reduce the marginal cost of onboarding more assets or processes or information. So if I can if I have a system called DataOps in place with a small team of people running it that can make it really fast and effective to deploy, a new DataOps instance, collect the data I need in the model format that I need and get it up to the cloud really fast, then suddenly I don't need all the data in the cloud. I know I can go get it when I need it at a very marginal cost. And a lot of the tooling we're seeing around that deployment of that is leveraging traditional CI/CD, almost DevOps technologies from IT, right? Like, how do we leverage Docker? How do we control our data models and Git or other technologies, and then push that down to the edge, kind of on demand? And then the other piece of that is, I always think the end goal of DevOps or DataOps is, how do I have a team of 6 people that can manage this thing across my entire corporation? And maybe that's 10 factories, maybe it's 100 factories. And what does that mean? It means you need to use CI/CD processes to deploy and manage. You need limited involvement from the OT folks, right? Like it can't be a heavy lift for them to get in and use if they even need to. And the other piece is you just need to monitor it so that if something does go wrong, someone's notified right away and can address the issue at scale, right?
Yeah, it sounds like you're introducing a lot more agility into a factory situation, which is normally really rigid.
Exactly. At the same time, not messing with any of the factory stuff at all, right? Like you can't go down there and say, you need to install all this new hardware, all these new applications, go change your HMI. Like that's most OT people are going to push back pretty hard on that.
Yeah, absolutely. And I want to say thank you to Venzel, who submitted this question. Should you contextualize data at the edge or in the cloud? I think you want to give just a summary sentence there, Aron?
You can do both, right? We're not going to tell you where to do it. It's our opinion that you should do it at the edge. And the DataOps technology is how you do that at scale at the edge and reduce the marginal cost of onboarding new assets, making changes to data models, all of that. I mean, our most advanced customers are focused on that scale problem, and DataOps is a solution, and that's edge-based contextualization.
Is it fair to say that the Intelligence Hub is most often deployed at the edge?
Yeah, I don't know if I'd have a metric, but I'd say the majority. Right? But we're also deployed in the cloud for other use cases as well, but majority deployments on the edge.
Great, thank you both. I'm going to launch a poll now. So who's driving DataOps in your organization? DataOps has been sort of around for a long time, a concept maybe it was introduced by IBM a decade or more ago, but has really applied to IT, and now we see it moving more into the industrial space, and we're trying to help champion that. So who's driving it? Is it IT in your organization? Is it OT on the operations side? Is it your executive leadership team? Or yikes, is it no one? And we'll let some more responses come in. Yeah. I think this looks about how I thought it would. I'll give it another 10 more seconds. I will give you a spoiler that executive leadership is pretty low, and I think that seems to be okay as long as executive leadership is bought in on the concept of data ops and applying these kind of technologies. Okay, I still have some coming in, but I'm going to go ahead and close this poll. You can see that if you head over to your closed polls, that IT is leading the way with no one in the second runner-up position right behind. So it's great that you're all here today, and hopefully you're taking something away from this discussion that you can take back to your own organization. Okay, let's jump back in to the panel discussion. And so,
Torey, if I can just comment on that, for
yeah,
everyone
please.
out there, you know, so leadership is you know, I think we've seen the same thing. IT is providing leadership, but really it's got to be a combination of the teams, and they've got to be working together. And the success that we're seeing is when you have strong collaboration between IT and OT. And IT often becomes leadership because they're the ones who are supporting the target systems and the target personas for the data. And they also have a lot of great experience in rolling out systems across the enterprise. So they can provide a lot of leadership there. But they also need to be working closely with OT because they're the source of the data and they're the domain experts that can really provide this contextualization that is required. And trying to do the whole thing with just an IT team, they often try and do it in the cloud, and they often really struggle. And a lot of it comes down to the persona as well as the technology and the challenges of timing. So
yeah.
Yeah, I mean,
Thank
IT
you.
is the one dealing with the problem of a bunch of junk data in the cloud, so that doesn't surprise me that they're leading the solution.
Yep, 100%.
Guys, let's transition over to talking about the sometimes elusive concept of UNS, or unified namespace. Many of you know that HighByte Intelligence Hub in the latest version 3 release added an MQTT broker. I'm guessing we're going to talk about that as this comes up now. So my first question is, how would you define UNS, and how can it be achieved, which is a pretty big question. John, you want to take this one first?
Yeah, let me jump onto this and let me just briefly touch on. So UNS is essentially just a consolidated location or structure where we're placing industrial data that can be used by the business and can be used by the OT team. And that data often spans both business and industrial applications in order to pull it together. So for instance, it can be everything from data out of the ERP system to the MES, the SCADA systems, the CMMS, quality systems, supply chain systems, all the way down to sensors and information. So it's that consolidated structure that we can put data. Now, a very common and widely used design pattern for that is an MQTT broker, because it gives us this ability to consolidate a lot of data and to structure it. And structuring, when you're putting a lot of data together, you really need to provide structure. So with the unified namespace, we're using the ISA 95 hierarchy or organizational system of company, site, area, line, cell, asset as a way of structuring it. It's a very logical approach that's generally understood by various or by all of the people who need access to the data. Much more than, say, how the control system is structured, which would be a very different approach. And then when we talk about what data goes into the unified namespace, it's the beauty of it is that we can put data at all the different levels. So at the site data, at the site level, we may be pulling things like profit and loss or schedule. At the line level, we may be doing certain line metrics. So it could be OEE, or it could just be, output and yield and quality and whatnot. At the site level, we could look at compliance, and then at the asset, we may be doing predictive asset maintenance. But the key is that we can have all that data together in one common use location to get the current view of the data.
Good. This is really helpful. Thanks, John. Sometimes it helps to take a concept like that and see it in a much more tangible way. Let me ask why. Speak a little bit more about why this is so attractive to manufacturers.
It just really becomes a central location that people can go and get access to information. And one of the overwhelming concepts that we hear from people is we need to get business decision makers, whether they're in different departments or even on the line, we need to get business decision makers access to information quickly, efficiently, and at high resolution. And this becomes a central place to put all that data. So I think it's just really access, and it's very much democratizing the data, providing it to the enterprise, whoever needs it.
Good. Okay. So Aron, play devil's advocate for me every and tell me something negative about the UNS. Not negative per se, but everything has to have everything has to have a blind spot or a piece of kryptonite. So where are the challenges in UNS?
Sure. Before I even do that, I mean, shout out to Walker, Reynolds and Intellect for creating the concept and kind of evangelizing that, because I think it has a ton of great things, right? Like John said, this democratization of data. I think, like at the core of UNS today, right? It's an MQTT broker. It could be Spark-Plug-B is the most common protocol to send over that today, with a lot of devices and applications starting to support that. But it could just be JSON as well. So like part of the core of UNS today is locked into MQTT at a technology level, right? And what that means is MQTT is report by exception, which is great. It means a single device can publish and multiple clients can come in and listen if and when they want and access the data. And that's part of the benefit of UNS. Some of the challenges of report by exception is that not all use cases for data transfer in the factory are report by exception, right? You have more transactional type queries, like I want data out of the MES system at a certain time, to look at a purchase order or whatever, or order status. And today UNS doesn't really have a way to route a transaction through. You can kind of hack it, but it's not great, right? The way it's done UNS is you just have something that pulls that database and tries to publish it on change, and like that SQL table, for example. So that's not quite transactional. You don't know at a current point in time, is this the actual transaction or information that's there? So that's one problem. The other problem that we run into, I feel like even a year ago we were answering this, is what about history, right? Like UNS is a report by exception, which is great. It's lightweight, but it has no ability to keep the history of data events like streaming technologies like Kafka or other things would support, right? So it's kind of missing that historian feel in the factory today. And there's a use case for being able to come in and give me the day's worth of data that came through on this topic, for example. So there's no off the shelf or standard solution for that, right? You have to come up with a custom. The other issues are just some of them around Spark-Plug-B, and it's an early protocol and it's being worked on. So I think these will be addressed. But things like the birth certificate, there's scale issues that if you have a lot of devices online, use a client have to come in and request a birth to see the schema of those devices, what they support. That today that'll cause all the devices potentially to come up and publish a birth certificate, which is pretty inefficient, because the broker has that information on what the schema is. It seems like there should be a way to just request it from the broker and not bother the device. And there's other subtle things too, like in manufacturing, we just have unique requirements, right? Where I've got all these boilers, say, hooked up to the UNS, and I just want to know when one of them goes above a certain temperature. That kind of smart subscription logic, there's nothing built inside of MQTT natively to support that, even over the protocol layer, right? And it's interesting because that's kind of like an OPC UA does do that. Spark-Plug and OPC UA kind of complement each other, kind of compete, like everything in manufacturing does. So it's kind of like they both have pros and cons, and those are just some of the cons of Spark-Plug. OPC has its own stuff, and we won't go off on that. But I think part of the reason we created our own MQTT broker technology in 3.0, right, is because we felt like that's a core piece of technology. We feel like UNS is here to stay. We want to own that piece, at least at the factory level, because we want to easily onboard customers, right? And the other thing we want to do is we want to be able to kind of poke at some of these holes in UNS in the factory and be able to create solutions maybe ahead of the standard bodies that we could eventually move into standards. Because again, it's MQTT that's used throughout all kinds of use cases. You know, HiveMQ, for example, Netflix is one of their customers. I'm guessing Netflix's requirements for an MQTT are very different than the factory floor. That also said, we created our MQTT broker technology. The goal is not to lock customers into that. The goal is to give them a quick on-ramp. And then if you want to go use it, HiveMQ, EMQX, et cetera, because you need high availability or other features, we want to make it easy for you to migrate to that.
That's great. So, and I think we've started to address this. Sebastian wrote in a question when they registered saying, you know, how to set up a UNS and structure that data. You know, do we have a recommended pattern? Is it the broker? Is it, or what about data lakes and how do they play into this? Is that complementary or is it a replacement? So maybe just talk a little bit about sort of ideal structural pattern, or maybe we don't have a one recommendation and it depends on the user. Can you just comment on that a little bit of how to structure it?
Yeah, certainly. So it's what John showed, kind of that ISA 95 hierarchy is the standard. Sparkplug has some difficulty in laying that out, given its kind of topic structure today. But again, I think the working group in Eclipse is working on that. But that's kind of the way to lay out the broker namespace. In terms of like UNS architectural patterns, UNS is definitely in the factory. I've seen that certain use cases where people will kind of open up the pipe and send all the UNS data up to like IoT Core at AWS. It works, right? Because it's MQTT. What's interesting about those use cases is then you ask them, well, what are you doing with the data? Do you need all that data? And the answer is, we don't know what we're doing with it yet. We have some ideas, but so like it's the idea of we're pushing everything and we're not necessarily don't have the use case. So I think UNS is definitely more valuable in the factory today, where you can, like John said, democratize the data really easily and give access to it. When you start to get to data lakes are not necessarily report by exception, right? They're storage, so that's very different. The patterns we see are with UNS and MQTT, you can easily open up a topic namespace and publish that to the cloud natively. So people will publish parts of the namespace that they need, but it's much more common to put like HighByte or another solution in there that can read the local UNS and then do the translation to whatever cloud service you want to push to in their native format more efficiently. It's generally going to be more cost effective and land the data directly how you want to use it.
Great.
I think I would
Thanks,
add though that the UNS unifies the namespace of the MQTT broker. Once you've done that, being able to then take that namespace, the pieces of it, the pieces, to Aron's point, the pieces that you need, and then publish them to the cloud is much easier, because now we've already unified it. We've standardized it. We've normalized the data based on the need and the use case. Now we can publish those to the cloud as needed, and store them in a data lake, so that you're kind of unifying the namespace of the data lake with a small u and a small n versus creating a unified namespace. But you absolutely get a lot of value by unifying that data, standardizing, normalizing it, publishing it up to the cloud, utilizing various tools where you can buffer it locally and publish files up to the cloud depending on the latency and depending on the needs are really powerful, to then get that history access that Aron was talking about earlier. Sometimes people need that history. The data lake is a great approach to storing that.
Great. Thank you both. Let me go ahead and launch this poll now on UNS. How critical is the unified namespace to your digital transformation? Recognizing that some of you may be coming to this webinar today really thinking about UNS for the first time. So not relevant, unsure, evaluating now. Is it important? Is it critical? And responses are starting to come in now. It's great. It's a really big mix. Interesting.
It's funny. I don't know about Aron. I'm not able to see it as it's coming in. So I'm excited to see what the results are.
So I have all the secrets.
You have all the power, Torey.
I like that, John.
Yeah.
All
UNS
right, let's see.
An OT, on IT side, they're skeptical, I would say, still,
yes.
of UNS is a fair.
Okay, I'm going to close the poll. We've gotten a lot of responses on this one, the
Great.
most so far. Okay, closing it. Head over to the closed polls to check this out. A big mix. So 43% saying it's important, 29% critical, another quarter saying they're not sure, but they're trying to figure that out now. Pretty much no one thought it wasn't relevant. So really interesting.
Yeah.
Thank you everyone for providing your feedback. Okay, so now let's head into the last piece of this panel discussion. And I think this is a really interesting question because, we had several registrants ask questions around other technologies in our space, like IoT platforms and SCADA solutions that also have their own, inherent modeling or contextualization capabilities. So let's start here. How have architectural patterns changed in the last 12 months? And where are they going? And Aron, I think I'll ask you to start this one.
Yeah, sure. And then John, you can fill in the blanks. See how I do. But it's becoming clear that DataOps is a thing. I think even a year ago, we were certain it was a thing. I think the market maybe a little less. So I think over the last 12 months, given our traction, the traction from just various customers, et cetera, I think you can see that it's a profession, just like John laid out in the beginning. So that's clear. In terms of like architectural patterns and what's changing, when you look at the landscape of solutions that could do this, right? Because there's in manufacturing, like every system overlaps in capabilities at some level. Like we all compete even when we partner. But
Yeah.
if you look at that, if you you kind of drew a diagram of the different solutions, if you look at more of the OT solutions that can start to accomplish this, it's generally a heavier lift, right? Because they were designed HMI, SCADA, et cetera. They weren't designed necessarily DataOps. So the amount of work you have to do at an individual installation is a little higher, a little more hands-on, maybe some custom scripting to leverage some tools. The biggest problem is the scale problem when you use traditional OT tools, because they weren't designed to say, hey, I have to replicate this across. You go to a customer, they have 50 facilities, they'll have the same SCADA, and every SCADA is configured differently. And we all know this, right?
Mm-hmm.
So they're very individual.
They all have the same SCADA, Aron. Most of the people, they've got like 5 SCADAs across 50 locations.
That's
so
true.
Who knows, right? 5
Yeah,
different
I made
brands.
that assumption.
Yeah.
So when you get to DataOps and you say, okay, I want to deploy the same use case across 50 factories, it's tough to do that because those traditional tools don't have those kind of capabilities, or they're never designed with kind of that intent. If you go the other side and you look at traditional IT tools, and I'll just use MuleSoft as an example, they lack the industrial knowledge to connect to the industrial assets and deal with the time series and transactional and the different data sets that we have in the factory, right? They can do the kind of ETL stuff. So what's coming clear is in the middle, there's this DataOps, and it's ripe for kind of something that can bring both solutions together, has traditional IT technology or OT technology, can connect to OT systems pretty easily, but then it solves the scale problem, right? I think the other thing we're starting to see is that when you look at the IT side trying to make this decision, there are DataOps platforms that are purely SaaS-based. So they're like top to bottom, they're going to feed data into their own cloud-based application. What's becoming more clear over the last 12 months is that like DataOps is kind of like the old days work at Kepler. It's Switzerland. I hate to use the term, but Switzerland, right? You don't necessarily know what applications are going to need the data. So you need something that's independent that can easily push it to anything, not just its own custom application. So the SaaS model is difficult if you control too much of the stack, because you want something that's really flexible, connect to all kinds of systems. The other piece that's really interesting is the pricing model. And I'm not going to get into HighByte pricing here, but no one wants to pay for data ingest at the edge, right? Because they know if it's going to go up to the cloud, they're going to pay there too. So there's some solutions that are throughput based, and like that alone, you're kind of getting double taxed on the data as it moves through. So that's another piece architecturally that people consider when they're looking at DataOps solutions. The last piece, and I would say the biggest piece, is it's really interesting to see, as a developer, we use Git and Maven and all these like development technologies I've used forever, right? it's really interesting to see as IT takes over data ops, they're using those same technologies to manage data ops at scale. What does that mean? It means they're taking common configurations that exist across all the sites and they're backing that up in Get. They're using CI/CD tools like JFrog or others to manage the deployment. They're looking at Docker at the edge to be easily be able to spin up instances and use cases and pull that back. They're using technologies like Splunk and Datadog to monitor those edge solutions and detect problems. So they're using traditional IT tooling, the stuff that I use every day as a developer, to manage the deployment of these edge-based applications in data ops. And I think over the last 12 months, I don't think anyone necessarily is 100% there, but they're all moving in that direction. And it's very clear that in the next 12 months, that's going to mature pretty rapidly.
Good.
That's all I
John,
got.
do you have any? No, it was good.
Yeah,
John, do you have anything you want to add specifically about like SCADA or IoT platforms?
Well, yes, but to build off of what Aron just kind of ended with on the using various tooling, like CI/CD pipelines and Git and all of that, I think what people are realizing is that this isn't a one and done integration and environment. They're realizing that we need to put systems in place that allow this to be maintained over a long period of time. And the challenge is that a lot of proof of concepts and a lot of the way that people started was they were writing a lot of custom code to move data around. Every system has an API, and we'll just write some code to move it around. And that sometimes can be actually the fastest way to get a proof of concept up and running. But when you try to do it at the scale that Aron just talked about, and then you recognize that things are changing, the targets and the users of systems are changing. We're seeing, certainly cloud is growing very quickly, but we're also starting to hear about edge and being able to analyze at the edge and utilize data at the edge. And cloud will always be that orchestration engine, but some data will go to the cloud and some won't. As well as the sources are changing. We're hearing about people utilizing a lot of these new sensors to add more data, to collect more data based on specific use cases. So with that change, maintainability is like the secondary piece of scale, and you really need to figure that out. And you need to plan from the very beginning to solve the scale and maintainability. Otherwise, you will we've seen and heard of a lot of companies that have gone down dead-end pathways with their proof of concepts. Just don't scale.
Yeah. As a direct question, I would say, okay, you deployed it to all 50, you've got your models, you're ingesting data in the cloud, and then you found something, we need one more data point from all 50 sites. What's the cost to go do that? And that's the problem, in my opinion, you need to be focused on solving, because like John said, it's going to change.
Yeah.
It's not one and done.
Yeah. And analytics is really driving the I need one more data point. It's I just solved my analytic for today. Now I need to add more data to solve the problem that I have tomorrow. And
based on what we learned.
It's a lot. It's a very iterative and learning based approach that a lot of our systems in the past weren't really set up for. So having a software aggregation layer to manage all of that becomes very powerful. And so then, to answer your question, Torey, about IoT systems is, from our perspective, we see IoT platforms and SCADA platforms as both sources and targets for data. So they are very good at consuming data, structuring it for their own use case. Think of systems like Factory Studio or Ignition or ThingWorks. They've got tooling in place to be able to consume data and structure it for their own use. Where DataOps solutions really thrive is when they're structuring and delivering data for other systems to use. So being able to structure it for the delivery to Factory Studio, as well as for the delivery to an S3 data lake, as well as the delivery to ThingWorks, as well as the delivery to Ignition or to whatever, Power BI, that's where you need a different structure and a different design to the solution, where you're thinking about you have many sources, you have many targets, and you're standardizing and managing the flow and maintaining the flow of data across them, versus IoT platforms and SCADA systems that are really designed to consume and visualize and present to the consumer that data.
Yeah, no, that's very helpful. Thank you. And I think that answers, we did get a couple questions on that from Rick and Shyam. So thank you for those questions. I hope we address them well. If not, follow up with us. And you just mentioned the flow of data. So I want to pose one final question. Obviously, HighByte Intelligence Hub has evolved a lot, and we recently released version 3. Can we talk a little bit, just for a couple of minutes here, about data pipelines? And so those were just added, and I'd like to take, maybe Aron, you could show us a little bit about those before we wrap up here.
Yeah, sure thing. And I'm going to try to play a video I recorded. We'll see first time. Yeah, so we added the concept of data pipelines, and this video is just kind of going to show a simple flow that's pushing to a pipeline. And kind of the genesis of this is we've done a really good job traditionally in HighByte of collecting data from various sources, mixing that in a model, right, providing the context around that in a standard model, and then pushing that up to various platforms, whether it be a UNS, whether it be a data lake, et cetera. And this is just showing an instance. If I do a test read, it'll pull back some data. Where we've seen growth is like what people want to do post sending to the output, right? Like transform data, buffer data. So pipelines are designed, and you'll see here with more of a visual UI. So this flow is pushing to a pipeline where you can kind of lay out the flow of the data and do various transformations. Like this one's buffering the updates in every 5 minutes. So this could be coming from a UNS as an example, right? This could be coming from Spark Plug B. Each message payload, we're going to buffer for 5 minutes. We're going to convert that to CSV, and then we're going to land that in a data lake, right? And this is a really simple way to kind of lay those flows out. And likewise, we can branch off, do an average calculation, and push that average back to a UNS. So we could take the raw data coming from the PLC, do a 5-minute average and publish that back into the UNS. I'm just showing here, you can easily tap into that flow of data, and those will run in parallel. So it's a really cool, super powerful feature. In 3.0, we really focused on the use cases of how do I transform protocols? So can I point at an OPC UA branch, read it, discover new tags that show up in that branch and publish those out via Sparkplug to kind of feed your factory UNS as one example, or MQTT, or the other way, go from Sparkplug to OPC UA. So we've kind of used pipelines to solve those cases initially, as well as just landing files in S3 and blob storage as an example. So being able to do that local buffering to basically optimize the size of the file and your cost of like S3 and blob transactions right at the edge. But this is just the start of pipelines. I think we're talking now internally around this feature and kind of how it grows. I mean, it's not too far-fetched to say at some point in the product's evolution, simple flows today will turn into simple pipelines. It'll be a more visual experience. I think our challenge is a lot of customers have asked, hey, can you be like Node-RED? We don't want to be Node-RED because, Node-RED is an awesome tool. I mean, don't get me wrong, but like simple things you want to do there sometimes in traditional manufacturing will require 20 blocks of state and configuration. We want to maybe go a level above that, but provide the same kind of visual feedback on the status of the pipeline and experience of just kind of building that out. So at the end, you can logically look and say, this is me gathering my raw data. This is me sending it to either the HighByte broker or any MQTT broker, and I can visually see how my UNS is being built out, through this kind of view. So we're pretty excited for this feature, in advanced versions of the product, and 3X we'll continue to build it out.
That's great. Thank you, Aron. Good. Okay. There's quite a few Q&A, and I know we're at time on the panel discussion, but it looks like attendance is still really high, and I'm good to stay on for another 10 minutes or so if you guys would like to too, and we'll get through as many questions as we can for everyone before we close down to the panel. Does that work for you, John and Aron?
Sure.
Let's do it.
Yep.
Great. Okay. And for anyone else that needs to drop because they budgeted 45 minutes for this, a recording will be available, just to remind you of that. And you'll be able to see some of this discussion after. So, okay. Lots of questions have come in here. One question is, what is the future vision for HighByte now that 3.0 has been released? Who wants to take that?
I don't know if we discuss who. So let me just start with some broad things, and then Aron can focus in on the technology. I think scalability, maintainability, and leveraging solutions out there that's like the guiding light to where we go and what makes sense, and the ability to how can we work with bigger teams, how can we scale easily across multiple sites, how can we consume more data and deliver it. There's more and more data sources that are being brought in. Data is becoming actually partially structured from the start. And so, our goal is if it's already structured, we don't want you to have to restructure it. We want to be able to leverage that existing structure and then move that up to the target system and potentially add additional context to it if needed. So being able to hit, remember that diagram that I showed with the levels of context, data could come in at various levels, being able to, and some systems may want it at other levels, not that finalized payload. So being able to pick it up at any level along the way and then deliver it however the target system needs it is where we're going. And then being able to do that at scale and maintainable and leveraging, like Aron had talked about earlier, IT and enterprise IT solutions orchestrating from the cloud is definitely a lot along the lines that I think about every day. Aron, you have other thoughts?
Yeah, I think the scale long term is our differentiator. So I think we're definitely focused on there. Just as an example, the whole like managing token access to cloud assets at the edge is an industry wide problem. We're very focused there, whether that's Vault integration or other solutions of how you rotate tokens out to the edge. That's part of scale. In terms of the product, we're really excited about on pipelines. There's a ton of functionality in HighByte that most users probably never see, right? Because we've been adding it really fast and going along. So we're really excited to step back and use pipelines as a way to start to visually lay that out and walk people through those features like templating, like indexing of inputs, and help with use cases and moving historical data, real-time data. I think on the UNS front, pipelines as well as a way to visually build out your UNS, that we've lacked that in the product. I think that's going to be really cool. Going after some of those features like historical data, access to UNS, transactions to the UNS. We're actually doing something in 3.1, adding like a REST server interface to the product. So you can come in and hit a topic or an input via transaction and actually run that through HighByte. So HighByte becomes kind of that hub to run transactions through. So we're excited for that. And then in UNS in general, we just, our ideal there is over time, we just want to be able to provide HighByte as a kind of a UNS out of the box as just one application you can use it for, right? So you don't need to go get an MQTT client or a broker and all the pieces that John, over the last year or two, we have to direct customers on what to use. Basically, you can start in HighByte, visually lay that out, and then, extend that to other brokers or whatever you need as you go. So that's just some of the, I know I just ranted, but there's no shortage of stuff we're going to do. And it's all,
I was just going to say, it sounds like you and the team are going to be busy, Aron.
Yeah.
Chris asked a great question, and it's more around the deployment of the Intelligence Hub and approach of federation. And that is, are you seeing teams have a central HighByte instance that contains master models, and then the model gets pushed out to, one hub or many running at the edge? Is that common?
Yeah. And this is one of the evolving spaces, right? Because folks that are focused on the scale problem are saying, okay, we want corporate-wide models for ML or whatever, and how do we manage those and as they drift over time? And what's becoming clear is like one solution is to use HighByte centrally, right, and pull those down, and we're going to make that really easy. But it's also becoming clear that like we might not be the ones managing the actual data models. For example, those might just be JSON based, stored in your own Git repository if they're using CI/CD tools. So how do we integrate with that and automate pulling those down and deploying those out to your sites really easily? So how do we fit into the process you want to use? I think there'll be standard ways, but I think there's going to be a number of ways people want to manage their model definitions. SQL could be another one. I mean, kind of spreads the gamut.
I think we've also seen, some people, depending on what their use cases and their approach is, they use a single hub at a site. Other people are using multiple hubs at a site. Could be that it's very different groups who are defining and consuming the data, and so they just want to keep it separate. It allows them the more flexibility. In the pharma space, it could be that some of them are more GXP type processes, and some of them are more flexible. Sometimes it's because of different network structures and topologies, and they need to be able to span across them. And so they may put one in the controls network, put another one in the business network, and then push the data across the firewalls from one to the next. So there's lots of different design patterns that we've seen. We're certainly we're adding capabilities to make it easier. In fact, our tagging functionality that we added in 3.0 makes it easier for multiple people on a team to be interacting with a very large project, because now you can filter the view, you can filter the permissions and things like that. However, it's it definitely evolves, and it varies from one customer to the next.
Thank you. A couple technical questions here around broker concept and UNS. The first one comes from Ivan, who asked, do you recommend publishing complete address space from PLC to the broker to avoid future changes? Is that possible with HighByte?
Would I recommend it? Probably, yeah. So you can connect. HighByte doesn't have a lot of direct PLC connectivity, and it's not really our wheelhouse, and we don't have a lot of plans to go and build drivers, right? If we can connect to the PLC over OPC UA and or OPC UA server, that's probably what our preferred method to get the data, just because that fits better in the existing ecosystem with HMI and all that. That said, since it's on, usually UNS can get away with publish everything because you're hosting the broker on the site. The cost of the brokers can handle a lot of data, and the cost of onlining, depending on the PLC. I mean, don't hook up a control logic to like 100,000 tags. That's probably too much, right? But the cost of publishing all that is not, it's nothing, right? That cost, again, once you get to the cloud, is different because you're going to get charged on throughput. So as long as it's not like a crazy amount of tags, tens of thousands, maybe, I don't think that's a huge deal to just open that up and publish the majority of it to the UNS so it's available when you want to use it.
I think the challenge that I would question, though, is, how well is that data laid out for the consumers of the data? And if the OT team is using it and they're using it to consume into their SCADA system, then the namespace that's been defined in the PLC is probably the namespace that you want in the SCADA system, or at least a good starting point. If you've got other users, they're often not going to understand the structure that's been defined in the controls environment. And so you really want to structure the higher levels parts of the UNS, like the line and the work cell, with kind of curated data, and that's where HighByte comes in. And you're right that if changes happen on the PLC, then you're going to have to change other systems. That's one of the reasons that we designed the Intelligence Hub to be used by the persona of the OT engineer, so that it could be part of their change management system. And it really needs to be, so that as things do change on the factory floor, they update HighByte. But the beauty is that they don't have to. It's a pretty easy action. And HighByte can be that abstraction layer. So you drop in a new PLC with a new controlling, and it's just very easy to redo the mapping of it based on what's needed. So providing that flexibility and that agility is really how we designed the Intelligence Hub, so that you could handle the changes that occur.
Great, thank you. And I think with that, we're going to have to draw this to a close. What I think we got to maybe a quarter of the questions that were submitted. Yeah. So this tells me that we probably need to do these more often, and maybe we need to start having some HighByte office hours or something where everyone can come in and ask these kind of questions and get real-time responses. If we didn't answer your question today, feel free to reach out to us by submitting the contact us form in the site, or reaching out to sales@highbyte.com. Alternatively, we'll go through all of the questions too, and try to follow up with some of you individually after this, just to make sure you got the information you needed. So again, the recording will be available soon. Reach out to sales@highbyte.com, or myself, John, or Aron, if you need access to any of the materials we shared. And with that, I'll just say thank you so much for joining us. And I appreciate everyone's time, and we hope to see you again soon. Thank you.
Thank you. Thanks, Torey. See you, Aron. Thanks.
See you.
Bye.